Welcome to another Geography 215 math video. This math video is for Chapter 11. The learning objectives for this video are to learn about cloud development, to learn about stability, to learn about capping inversions, to learn about the flash to bang method, and to learn about hailstones. Some of these problems in this chapter are conceptual. Others, you'll need to use math. For question 1, we have seen forms of this question before. This question is multiple choice for the most part and asks you to reflect on past learning. Do you have the WAR, DAR charts handy that were provided in the Chapter 5 math notes? If not, go back to page 197 and reread the section on how air becomes saturated. This will get you through the first and second responses. The third response requires you to practice the mathematical calculation again. And the fourth response is about you recognizing a freezing temperature. Question 2 we have seen before as well, or at least a few forms of it. Back to Chapter 6, pages 227 through 230. Stability is about the tendency of an air parcel to rise or sink through the surrounding air. Look at the multiple choices and first ask yourself, which are indicated warming and which are indicated cooling? There are two of each. Figure 6.21 on page 227 is also helpful and tells the correct response. Hint: what is the WAR? Remember, you are asked about a cloud, which means the air is saturated. For question 3, what is an inversion? If you have forgotten how this is portrayed on a Stuve diagram and cannot yet envision the standard atmosphere profile, then review it by looking at the figure on page 230. This will help you determine what an inversion is. For question 4, read about lightning on pages 447 through 450. You will find the value needed for the calculations within this section. As a rule, thunder takes about 3 seconds to travel 1 kilometer, or 5 seconds to travel 1 mile. If you must wait 9 seconds between lightning flash and thunderclap, the lightning is about 3 kilometers or 1.8 miles away. This is the flash to bang method of determining the distance to a thunderstorm. Let's take this problem. What is 11 seconds in kilometers away? First, we want to take the conversion, which is 3 seconds per 1 kilometer, as stated in the general rule. And that equals 11 seconds, but we don't know how many kilometers that is away, so we'll put that as x. So you want to cross multiply, so 3 seconds in x, and 11 seconds and 1 kilometer. So you get 11 equals 3x. You will then want to get the x by itself, so you divide 3 by both sides. Eventually, that gives you your answer of x equals 3.7 kilometers. Therefore, your answer for this conversion is 3.7, which is 11 divided by 3. Question 5. Have you ever been bonked in the head by a hailstone? Even small hailstones can hurt. Read about hail on pages 456 through 459 and reference table 11.4 for size references. You may remember we learned about terminal velocity on pages 296 and 297. Question 5. A spherical hailstone with a diameter of 4 centimeters, or about the size of a ping pong ball, has a terminal velocity of about 30 meters per second. In order for this hailstone to remain suspended in the cumulonimbus cloud, requires an updraft of blank meters per second, or blank kilometers per hour. There's a conversion of 1 meter per second equals 3.6 kilometers per hour. To solve this problem, terminal velocity of about 30 meters per second, it will need an updraft of 30 meters per second to remain suspended in the cumulonimbus cloud. In kilometers per hour, you want to take 30 meters per second and multiply it by 3.6 kilometers per hour. That'll give you 108 kilometers per hour. Therefore, the hailstone requires an updraft of 30 meters per second or 108 kilometers per hour. This ends the Chapter 11 math video. As always, please let me know if you have any questions. I hope you all have a great week.